I'm Miko. I'm going to review our homework from last Thursday. I'm not going to be able to be in class on Tuesday. I think I indicated that in an email because of a death in the family, and I need to attend a funeral. So I'm going to go over the homework. Please watch this video. I guess you are watching it if you're listening to me. As we'll have a little quiz on Thursday that will be the same thing, just to validate that you watched it. So I want to do some of the homework questions. So I thought the first one that I would choose would be number 15. This is on page 78. And I'm going to read that to you and then also do it. So the Nichols restaurant chain regularly conducts surveys of its customers. Respondents are asked to assess food quality, service, and price. The responses are excellent, good, and fair. They are also asked whether they would come back. After analyzing the responses, an expert in probability determined that 87% of customers say they will return. Of those who so indicate, 57% rate the restaurant as excellent, 36% rate as good, and the remainder rated as fair. Of those that say they won't return, the probabilities are 14, 32, and 14 respectively. What proportion of customers rate the restaurant as good? So let's take a look at this. So first thing we want to do is we want to define our events. And we have some various things going on here. But one of the things we have going on is the customer either returns, we'll say R as return, and RC is do not return. Remember, the complement is the opposite, so RC is do not return. We'll also say E, excellent, good, and fair. Okay, so those are, I would write those out, but I'm being lazy. So E is excellent, G is good, F is fair. Now the first thing we have to determine is what happens first on the tree. Not necessarily what happens first in real life, but what happens first on the tree. If we look at this, it says overall probability is 87% of customers say they will return. That's an overall probability. That's not a conditional probability. So that's going to be the first branch because look, these other ones, of those who so indicate, that means given that they will return. These are second branch or conditional probabilities. So the first branch of our tree is the probability of returning is 87%. And it doesn't tell me what the probability of not returning is, but via the complement rule, I can figure that out and say that is 13% because it asked to add to 100. Now further, it said of those that will return. So given that they will return, it says that 50%, 7% rated as excellent. So given return, the probability of excellent is 57%. The probability of good given return is 36%. So the probability of fair, it doesn't tell me this, but I know these have to add to 100, so that's 93%. So this one has to be 7%. Down here, the same thing. The probability of excellent, given that they won't return. The probability of good, given that they won't return. And the probability of fair, given they won't return, are 14%, 32%, and 54% respectively. So if I look at this tree, I have 6 outcomes. Return excellent, return good, return fair. Don't return excellent, don't return good, don't return fair. Let's see what the question's asking me for. It says, what proportion of customers rate the restaurant service as good? So I have 6 outcomes. Of those 6 outcomes, there's only 2 that end in good. Returning good and not returning good. So 87% times 36%, and this one would be 13% times 32%. So let me do that math. So this one is equal to 0.3132. And then 13% times 32% is equal to 0.0416. So both of these are good, so I need to add them together. So 0.3132 plus 0.0416 gives me 8, 4, 5. So the answer to this is about 35%. Okay? So the key with this one, and this is why I want to do this one, is you need to determine what goes first on the tree. Because you're thinking, hey, they rate excellent, good, or fair first, so shouldn't that happen first on the tree? Well, even though that's chronologically what they do first, the way the conditional probabilities were given, or the probabilities were given, it says the probability of returning overall is 87%. So that's not a conditional probability. That has to be the first branch. All the other probabilities were given as conditional. Okay, so that is number, what is that? Number 515. Okay, so hopefully you're able to do that one. Let's do another. Okay, so I think a good one is, let's do 16. Okay, 16, which is the next one, we'll do 16 and 18. 16 says, a financial analyst estimates that the probability that the economy will experience a recession in the next 12 months is 25%. I didn't hear a condition there, so that must be a first branch thing. That's just overall probability of recession is 25%. She also believes that if the economy encounters a recession, that sounds conditional to me, the probability that her mutual fund will increase is 20%. If there is no recession, the probability the mutual fund will increase in value is 75%. Find the probability that the mutual fund will increase. All right, so as I always do, I'm going to ask you to define the events. So we have recession, so I'm going to call that an R. And I'll say R complement is no recession. Our mutual fund can increase or decrease. So I'm doing MFI for mutual fund increase. I could have just done an I if I wanted to. And MFD for decrease. I could have just done a D probably, but I'll do MFI and MFD. So the first thing I'm going to draw on my tree is the recession. She estimates a 25% chance of recession in the next 12 months. And even though it doesn't state it via the complement rule, the probability of no recession then is 75% because they have to add to 100. Now it says, if the economy encounters a recession, the probability that our mutual fund increases. So given a recession, the probability of MFI is only 20%. So that must mean, given a recession, the probability that it goes down, or even I guess, is 80%. Okay, so given, at this point we're given a recession, probability of an increase is 20%, probability of a decrease is 80%. If there is no recession, perhaps that's a rosier picture, the probability that a mutual fund increases is very much better, 75%. The probability that it doesn't increase or it decreases then is 25%. So I have my tree and I have 4 outcomes. Recession, increase, recession, decrease. No recession, increase, no recession, decrease. It is looking for the overall probability that the mutual fund's value will increase. Well, where does it increase? Of the 4 outcomes, it increases here and increases here. To get this probability, I'm going to do 20% times 25%. That's called the multiplication rule to find the probability of R and MFI. I multiply along the path. 20% times 25% gives me 0.05. Probability of no recession, but still an increase. 75% times 75. That gives me, I believe, 0.5625. It does. So 5% plus 56.25% gives me 61.25%. So that's my answer. Okay, and remember what we're employing here is the multiplication rule, because what we're figuring out is, this is the probability of recession and mutual fund increase, and that's what the multiplication rule says. Multiply along the path, that will find that. This is the probability of recession and mutual fund decreasing. That would be 25% times 80%, which would give me 20%. Okay. This is the probability of a mutual fund no recession and a mutual fund increasing, which we found is 56.25. And this is the probability of no recession and mutual fund decrease, which is 75% times 25%, which gives me 18.75. So if I add up all of those, guess what they add to is 100%. So all this kind of has a balance to it, a beautiful, beautiful balance to it. So this is 5/16. All right, the last one I'd like to do is in your book, and it is number 18. Because sometimes students think that all trees are symmetrical, and they're not, and this one is not. It says a telemarketer sells magazine subscriptions over the telephone. The probability of a busy signal or no answer is 65%. If the telemarketer does not make contact, if it does make contact, the probability of 0, 1, 2, or 3 magazine subscriptions sold is 5, 25, 20, and 5% respectively. Find the probability that in one call she sells no magazines. All right, so we have to think about what happens first in this situation. And what happens first in this situation, this is 18, is we either get through or we don't get through. So the probability of, I'm going to say A complement is no answer. No answer or busy signal. 65% of the time we have A complement. So A means someone answers. So let's draw that first branch. Oh, and then we have 0, 1, 2, or 3 cells, I guess. We can, when we get through, we can sell 0, 1, or 2, or 3 things. And I would define those: 0 sales, 1 sale, etc. So let's draw the tree, though. So the probability of an answer, if the probability of no answer or a busy signal is 65%, then the probability of answer is 35%. This tree ends down here because, think about it, this branch anyways, if no one answers, hey, we can't make a sell, so it ends there. That's an outcome. No answer, done. Okay? But if someone answers, we have the possibility of making 0, 1, 2, or 3 sales. So the probability of 0 sales, given that someone answered, probability of 1 sale, given someone answered, probability of 2 sales, given someone answered, and 3 sales, given someone answered. And those probabilities are, looks like 50%, 25%, 20%, and 5%. All right, so it's asking for find the probability in one call she sells no magazines. Well, Here we sell, there's 1, 2, 3, 4, 5 different ends of the tree. 1, 2, 3, 4, 5, so 5 outcomes. Where are the outcomes where we sell no magazines? Well, no one answered, so multiply, this is just 0.65. No one answers, so 65% of the time we sell no magazines there. Probability of answer and no sales is 50% times 35%, which gives us 17.5%. So we add those two together, and it looks like roughly 82.5% of the time, not roughly exactly, we make no sales. So only if that's the odds, then roughly what, 17.5% of the time we make a sale or more. Okay, so hopefully you guys are able to do this. As I said, on Thursday we're going to start the class with a short probability tree question. And what I'd also like you to do for Thursday is I want you to, and this is kind of a weird assignment, but I would like you to figure out, we mentioned what the odds of winning the Powerball is, but what I want you to do is I want you to use a probability tree to figure out the odds of winning the Powerball. And this is the key, okay, this is the key paragraph you need. We draw 5 white balls out of a drum with 69 balls and 1 red ball out of a drum with 26 red balls. So you have to match all 5 white balls and the red ball, which is known as the Powerball, to win. So the odds of winning, okay, the odds of winning, now let's see if I can find that on the site, there we go. The odds of winning, of matching all 5 balls in the Powerball, is 1 in 292 million. So here's what I want you to do. I want you to draw a tree. Now obviously you're not going to draw the whole damn tree, but I want you to draw a tree that shows the path of winning, matching all 5 balls and the Powerball. And if you multiply along that path with a probability tree, multiply along that path, you should get 1 in 292 million. So we'll do that in class Thursday, but I want you to try it for homework, okay? Because we can come up with that probability given the things that I taught you, I guarantee you. So sorry about missing class Tuesday. I need to be at the funeral. Hopefully this will keep us moving forward. And we're kind of done with chapter 6. So we'll talk about doing some kind of assessment, chapter 5, I'm sorry, some kind of assessment here very shortly. Have a good day. Talk to you soon.